Hello friends, today we study about the way optics and the optical instrument. Then we study about the image formation by a quantum radar. In the last class, we study about some rules, that is a Cartesian sign convention. According to the Cartesian sign convention, we know that all the distances are measured from the pole and the distance above the principal axis is taken to be positive and distance below the principal axis is taken to be negative and the directions are taken to be positive in the same direction of the incident ray. Then see some image formation due to the concave mirror. And we know that the concave mirror are used to find out the different images. So concave mirror gives the real as well as a virtual image. But the convex mirror always gives the virtual image. The image is formed same side to the object, that is known as a real image. Or the image which is found out due to the converging rays is known as the real image. The image which is found out due to the diverging rays is known as a virtual image. Then here, what is the image formation due to the concave mirror? Means when the position of the object is changes, the image is also changes. So here, in the last class we study about that. If the object is, if the object is, if the object is at a 2 means at the center of curvature. So now draw the ray diagram. For the ray diagram, we use the concave mirror. Concave mirror is that where the polygonal surface is towards the radar medium, towards the air. Suppose the midpoint of the concave mirror is known as a pole. Draw a straight line which is passing from the principal axis. That is, the principal axis is that which is passing from the principal focus and the center of curvature. A straight line is known as the principal axis. Here the object is situated at 2 If the extended object is there, if the extended object is there, if the extended object is situated on the center of curvature, to draw the image formation, take the first line which is the incident on the center of curvature on the mirror, which obeys the laws of reflection and the rays reflected back. To find the image formation, another one ray which is the incident on the pole, give the arrow mark. And from the pole, again the ray of light is reflected and there is an image is formed. So here, when the object is situated on the 2 the image is as it is. Means height of the object and height of the image is same. So when we study about this, we say that when the object is at the 2 the image is as it is. The image is as it is. Is as it is. See here, the image is inverted. The image is the second point is the image is inverted. Inverted. Third point. Here, the image is found out due to the converging rays. So the image is real. The image is real. The image is real. So these are the points when the object is at 2 Then here second, when the object is in between, when the object is in between F and 2 means F and the center of curvature. Draw the again another one ray diagram. Suppose this is a concave mirror. Draw the polygonal surface outside to the surface. Midpoint of this is known as a pole. Draw the principal axis, a straight line which is passing from the center of curvature and radius of curvature is known as the principal axis. So we know that in the last derivation we study about that the distance of the center of curvature is the double of a focal length. Therefore, if this is a f, then this is a 2f, or this is also known as the center of curvature. Take the point in between f and 2f. If we take the extended object, if the point object is there, another one is the extended object. If we take the extended object, from the object number of light rays are arrived. Suppose the first light ray is incident on this. This is a straight line. Again, when the ray of light is incident on the mirror, which is a reflected back. So this is a reflected and passes from the principal focus. To find out the image formation, take the another one ray of light. Suppose the another one ray of light which is the incident on the pole. Again, it obeys the laws of reflection and the ray of light is reflected. So here, where both the rays are meet, there is a formation of an image. So here there is an image is formed. But the image is enlarged as compared to the height of the object. Means when the object is in between f and 3f, the reflected image is enlarged as compared to the object. Means the height of the image is large as compared to the height of the object. Therefore, the image is, when we explain about this, the image is enlarged. The image is enlarged. Enlarged. Second point, the image is found out due to the converging rays. So the image is real. Image is real. See here, the height of the object means the arrow mark is upward. Here the arrow mark is downward. Means the image is inverted. The image is inverted. Is inverted. So this is the second figure. When the object is situated in between focal length and the center of curvature, that time the image is found out. That image is enlarged. Means the height of the image is more as compared to the height of the object. As well as the image is found out due to the converging rays. So the image is real. And here the arrow mark is upward, and here in the image the arrow mark is in the downward. So the image which is found out, that image is inverted. So in this type, this is the explanation for the image due to the when the object is situated in between f and 2f. This is the third figure. When the object is situated on f, means when the object is situated on the principal focus, then what size of the image is formed? When the object is situated on the principal focus. Take the concave mirror. Polish the surface is outside. Draw a straight line where the object is situated on the principal focus. Suppose this is the principal focus here. When the object is situated on the principal focus, that is extended object is situated on the principal focus. Suppose the ray of light is incident on this mirror. A straight line passing through this and it is an incident on the mirror due the arrow mark. The ray of light is reflected and this concave mirror is a converging mirror. So the ray of light is passing from the principal focus. So this is the ray which is passing from the principal focus. Take another ray of light which is an incident on the pole. Again, which apply the laws of reflection, that is the angle of incidence and angle of reflection both are same. So the reflected ray is moving in this direction. So here, this type of image is formed when the object is at the principal focus. Means when the object is situated on the principal focus, the image is at the infinity distance because both the rays are parallel and these rays are meet at an infinity distance. Therefore, when the object is situated at the principal focus, the image is found out at the infinity distance. So when we explain about this figure, first point, the image is at the infinity distance, at infinity. But the image is find out due to the converging rays. The image is find out due to the converging rays. So the image is a real. The image is a real. The image is a real. At the same time, the image is inverted. So the third point, the image is inverted. The image is inverted. So when the object is beyond 2f, the image is diminished. When the object is on 2f, the image is as it is. When the object is f at 2f, the image is enlarged. And when the object is on the principal focus, so the image is so enlarged, and which is found out at the infinity distance. But all these are the real images. But when the object is situated in between pole and the principal focus, when the object is situated in between pole and the principal focus, when the object is in between pole and principal focus. So see what type of image is found. Draw the figure. Suppose this is a concave mirror. If we take the concave mirror, in the concave mirror the polished surface is outside. Suppose this is a pole. Draw a straight line. That line is known as a principal axis. Suppose this is a principal focus. When the object is situated in between pole and the principal focus, so that time the ray is incident on this mirror, but the ray is not converges, the ray is a diverges. The ray is a diverges. So see here, this is a diverging rays, and this diverging rays is a come back from the principal focus, which is come back from the principal focus. This is the ray. If I take the another one ray, which is from the center of curvature, which is a normal to this surface, another ray which is passing from the center of curvature. See here, both the rays are meet, and there is a formation of an image. So see here, this is the image which is formed due to the concave mirror. The image is formed due to the concave mirror when the object is in between P and F. When the extended object is situated in between pole and F, that time the rays, those are called diverging rays, and the image which is found out due to the diverging rays, and the image is formed. But see here, this image is due to the diverging rays. So this image is known as a virtual image. So when we explain about this figure, the image is virtual. The image is virtual. The image which is found out due to the diverging rays is known as a virtual image. So this is a figure which is found out due to the diverging rays. So this image is a virtual. Means concave mirror use the real image as well as a virtual image. Means when the object is situated in between pole and the principal focus, that time the image which is a virtual. And second point, the image is as it is. The image is as it is means this is known as an erect image. So the image is erect. The image is erect. Image is erect. The image is erect. Third point, erect means as it is. So the image is erect. And the next point, the image is extended. The image is extended. Image is extended. Means magnified. object is in between pole and principal focus, the image is virtual because this image is find out due to the diverging rays. At the same time, the image is erect. What is the meaning of erect here? Erect means as it is. See here, this is the arrow mark in the upward direction. So here also the arrow mark in the upward direction. This image is known as an erect image. At the same time, the image is magnified. Means the size of a object and the size of the image, or the height of the object and the height of the image both are different. So the image is magnified. So in this type of concave mirror gives both the real image as well as the virtual image. So here next part, the image formation due to the convex mirror. Convex mirror gives always a virtual image because in the convex mirror the rays are diverges. So the image which is a find that is known as that image is a virtual image. So the next part, image formation by a convex mirror. Image formation by a convex mirror. Convex mirror is always give the virtual image. So take here convex mirror, in which the convex mirror, the polished surface is inside and the reflecting surface is outside. So this mirror is known as a convex mirror. So draw a principal axis. Suppose this is the pole. If this is a F, if this is a 2F, if the object, extended object is situated, the rays are incident on the convex mirror, but the convex mirror is a diverging. Means the incident rays are away from the principal axis. Suppose this is a diverging ray. Extend the principal axis. So this diverging rays is a meet to the another one side. The ray is incident. The ray is a diverges. Suppose this is a diverging rays. Imaginary light is a meet at a principal focus on the other side. Take another one light, which is a incident on the center of curvature. So here, where both the rays are meet, there is the formation of an image. So this is an image. Suppose this is a A B with the object. This A dash B dash with the image. This is an image formation due to the convex mirror. Convex mirror always gives the virtual image. What is the meaning of virtual image? The image which is a kind of due to the diverging rays is known as a virtual image. Then here when the object is situated on the principal axis, anywhere, when the object is situated on the principal axis, take the straight line which is an incident on the mirror, which is a divergence, and which is a comeback. Imaginary line which is an incident on the principal focus to the other side. Another one deviate which is a passing from the center of curvature. Where both the rays are meet, there is a formation of an image. Means here this is an object and this is an image. When we explain about this image formation, the first is the image is virtual. The image is a virtual. First point. See the second point. The image is a erect. What is the meaning of erect? As it is. So the image is a erect. The image is a erect. Is a erect. The image is a erect. Third point. The image is diminished because the height of the image is a less as compared to the height of the object. So the image is a diminution. The image is a diminution. Diminution. So these are the points related when the object is situated in front of a convex mirror. So here, what is the difference in between the virtual image which is given by the concave mirror and which is given by the convex mirror? So here, when the virtual image is given by the concave mirror is magnified. The virtual image which is given by the concave mirror is that magnified, but the virtual image which is given by the convex mirror is a diminished. So this is a difference in between the virtual image which is given by the concave mirror as well as the convex mirror. So here the concave mirror gives both the real image as well as the virtual image, but the convex mirror always gives the virtual image, and the virtual image which is given by the concave mirror is magnified, and the virtual image which is given by the convex mirror is diminished. Then next we study about the mirror formula. Mirror formula. Mirror formula. Observe the relation in between F, U and V, where F is known as a focal length. The distance between pole and the principal focus is known as a focal length. The distance in between the object and the pole is known as the object distance, and the distance in between the image and pole is known as the image distance. And all the three are denoted by F, U, V. So in the mirror formula, we study about the relation between F, U and V. We derive the relation in between the F, U, V, that is known as a mirror formula. So here, to study the mirror formula, this derivation is related for the phi mass. So to derive this expression, we use the concave mirror. We use the concave mirror. By using the concave mirror, we derive the relation between F, U and V. So here how to derive this? First draw the figure. First draw the ray diagram. In this give the aromas. So where the ray is incident and where the ray is reflected. So here first draw the aroma. So take the concave mirror. So in this concave mirror, take the object. Take the concave mirror. And in the concave mirror, polished surface is the outside. Draw a straight line which is passing from the pole, principal focus and the center of curvature. If the object is situated, if the extended object is situated beyond the C, if the extended object is situated beyond the C, if the object is a AB. So first draw the ray diagram, where AB is the object which is situated beyond the C. So first draw the ray diagram. To draw the ray diagram, take the incident ray. Suppose the first incident ray, which is the incident on the mirror. Draw a straight line, which is the incident ray. This concave mirror is a converging mirror, so which is a reflected back, which is a reflected back from the point. So this reflected ray is a passing from the principal focus, which is passing from the principal focus. To find the image formation, take the another one ray of light, which is the incident of the pole, which is the incident of the pole. So this ray is again reflected back, and both the rays are meet together. So here this is a reflected ray. Both the rays are meet. Where the rays are meet, and there the formation of image is there. So there is an inverted image is formed. There inverted image is formed. So the image is diminished and inverted. So AB with the object, and here this is a image. Suppose this is a dash and this is a B dash. So here AB with the object and A dash B dash with the image. The first ray of light is the incident of the mirror, which is a reflected and which is passing from the principal focus. Take the second ray of light, which is the incident on the pole and which is a reflected back by obeying the laws of a reflection. where both the rays are meet, there is a formation of an image. So AB with the height of an object, A dash B dash with the height of the image. This here, this distance. Suppose this is a point, if we give the name for this is a M. So from pole to the A, so that is a P to A. This distance is known as the object distance U. From P to A, this distance is known as the object distance U. This here the image is find out. This distance is known as the image distance V. From P to A, this distance is known as A. The V, that is the image distance. This distance is known as the object distance. This distance P to F, this distance is known as the focal length F. The distance in between pole and principal focus is known as the focal length. That is a F. And this distance is known as the object distance U, and this distance is known as the image distance V. Means by using all the values or by using these figure, we derive the relation in between U, V and F. So to derive this relation, we compare the triangles or we compare the figures in this diagram. So when we draw this diagram, we explain about this. Consider a object AB, which is situated beyond C. When from the object, the number of light rays are incident on the concave mirror. Suppose the first ray of light is incident on the concave mirror and which is a converges and passes from the principal focus. The second ray of light which is a passing from the pole and which is a reflected back, and when both the reflected rays are meet, there is a formation of an image. So this AB with the object and A dash B dash with the image. The distance between pole and object is known as the object distance U, and the distance in between the pole and this image is known as the image distance V, and the distance between pole and the principal focus is known as the focal length F. So in this type we derive the relation in between them. So to derive this expression in between U, V and F, consider it first the similar triangles. So see in this figure, there are similar triangles are there. So here, this A, B and P. A, B and P. So this is a curvature. So draw a perpendicular from the point F on the principal axis. So to consider the similar triangles, draw a perpendicular from M to N. Suppose MN with a perpendicular which is from the point M to the principal axis, that is a MN. Then consider the two similar triangles. These two similar triangles are ABP or ABN. Consider the similar triangles. Consider similar triangles. Similar triangles. Those similar triangles are ABN. ABN and ABN, and another one triangle is A dash B dash N. Consider the another one triangle, that is A dash B dash and N. A dash B dash and N. So consider the both similar triangles. Compare the similar sides. When we compare the similar sides, AB divided by AB divided by A dash B dash. AB divided by A dash B dash. AB divided by A dash B dash. Then other two sides are AP divided by A dash P is equal to AP divided by A dash P. Suppose the equation number 1. So see the figure. In this way, consider the similar triangles. Those similar triangles are ABP and the ABN, where N is very close to the P. That is ABN. And the other one similar triangle is A dash B dash and N of A dash B dash and P. The similar sides are AB and A dash B dash. So AB divided by A dash B dash is equal to AP or AN divided by A dash N or A dash P. So these are the similar sides. Then again compare the similar sides. Okay, first we consider these two triangles. Then we compare the another two triangles, that is A dash, B dash and F. This triangle A dash, B dash and F. And the another one triangle is this F, N, F, N, M. Take the other two triangles, another two similar triangles. Those similar triangles are, first triangle is A dash, B dash, F. And the similar another one triangle is F, M, M. Consider the other two similar triangles. Consider other similar triangles. Those are A dash, B dash, M. A dash, B dash, M. A dash, B dash, M. And the another one is F, M, M. And F, M, M. F, M, M. So this is the first one, A dash, B dash, M. And another the one is a F, M, M. Then compare the similar sides. When we compare the similar sides, M, divided by A dash, B dash. That is a M, divided by M, divided by A dash, B dash. A dash, B dash. M, divided by A dash, B dash is equal to M, divided by A dash, B dash. Then another one similar side is F, divided by F, A dash. F, divided by F, A dash. F, A dash. Suppose this is the second one. So here, can we compare these two sides? That is A dash, B dash, F. And another one triangle is F, M, N. In this we compare the two similar sides. That is a M, divided by A dash, B dash. Another one is N, or F, divided by F, A dash. So here, this M, and AB. M, and AB. Both are parallel to each other. M, and AB. Both are parallel to each other. And both are the similar sides. Therefore, M is equal to AB. M is equal to AB because both are the parallel sides. Therefore, the next equation is AB divided by A dash, B dash. AB divided by A dash, B dash is equal to Fn divided by Fa dash. Suppose this is the equation number 3. So see here the equation number 1 and the equation number 3. So see the equation number 1 and equation number 3. Where the one side is the same. Here the one side is the same. Therefore, the other side is also same. When the one side is the same, then the other side is also same. So compare that equation AP, that is a N, or that is nearly equal to P. Where N is very close to P. Therefore, we consider that AN otherwise AP because according to the Cartesian sign convention, all the distance are measured from the pole. So now primarily similar triangles apply ಮಾಡಬೇಕಂತ ನಾವು perpendicular ಹಾಕಿದೆ. But law ಏನದ all the distance are measured from the pole. So n is nearly equal to P. So convert that value n is equal to P. Therefore, this value AP divided by A dash P. AP is equal to, what is the meaning of AP here? See here, AP is equal to U. AP, that is a object distance, and this value is equal to U. And this A dash P, this value is known as a image distance, and this value is denoted by the letter P. Means AP is equal to U and A dash P is equal to P. Therefore, this is equal to, and the AP by A dash P is equal to U divided by P. Then AP is equal to AP. This distance is the object distance, and that object distance is equal to U. And here A dash P, all the distance are measured from the pole. Therefore, A dash P is equal to P. But see here, when we apply the Cartesian sign, all the distance are measured from the pole, and the distance are taken to be positive in the same direction of incident ray. So here, for the U, see here, see the figure. This is an incident ray. Is the direction of the incident ray is in this direction. Means the direction of the incident ray or the other mark in this axis. But when we measure the distance from the pole to this side, so both the distance are opposite. When we measure this object distance, we take from the P to the A. Means we move from P to A in the opposite direction. So to measure the distance from P to A, the distance is opposite, the arrow mark is opposite, therefore the object distance is considered to be minus. The object distance is considered to be minus because the direction of the incident ray in this direction and the distance are measured from the pole and we measure the distance from the pole in the opposite direction. So according to the Cartesian sign, the object distance is taken to be negative. At the same time, what about the image distance? See the figure? Incident ray is in this direction and the distance of an image is also taken from the pole. Means this distance is measured from pole to A dash. Means P to A dash. Means we measure in the opposite direction. Means the image distance is also taken to be minus. The image distance is also taken to be minus. Therefore, AB divided by A dash B is equal to minus U divided by minus V. Therefore, AB by A dash B dash is equal to minus U divided by minus V. At the same time, we consider the second triangles, that is a MN divided by A dash B dash. That MN is a very close to, very parallel to this. So therefore, we consider here AB divided by A dash B dash. So here this values are Fn divided by Fa dash. Fn divided by Fa dash. So see the distance Fn. Fn is equal to, Fn is nearly equal to Fp. That is A dash B dash is equal to A dash B dash is AB divided by A dash B dash is equal to Fn is which is a very close to the pole and Fa dash, this is the distance Fa dash. So this is equal to Fa dash. First one is a Fp. What is the meaning of Fp here? Focal length. And what about the focal length here? The distance incident ray is in the direction and we measure the distance in the opposite direction. Means this distance is considered to be minus. Therefore, Fp is equal to minus F. Fp is equal to minus F. Because all the distance are measured from the pole. Therefore, Fp is equal to minus F. This here Fa dash. Fa dash, this distance. So Fa dash means this value is equal to, Fa dash is equal to Pa dash. Why? Pa dash is equal to P. F is equal to F. Means Fa dash is equal to, so here Fa dash. Fa dash is equal to, see the value of Fa dash? Fa dash is equal to, Fa dash is equal to, Fa dash is equal to PF. Fa dash is equal to, this value is equal to Pa dash minus PF. So Pa dash minus PF. So Pa dash minus PF because Fa dash is equal to, we take here Pa dash minus PF and here Pa dash is equal to, Pa dash is equal to image distance and that image distance is equal to V. But this image distance is in the opposite direction, means this is a minus V. And PF is equal to focal length and this focal length is equal to minus F. Therefore, minus plus F. Therefore, Fa dash is equal to minus V plus F. Means this value is equal to minus V plus F. Suppose this is equation number 4 and this is equation number 5. So here we got the value AB divided by A dash B dash is equal to AB divided by A dash B and we got here AB by A dash B is equal to minus U divided by minus V. Second, here Fn divided by Fa dash. Fn by Fa dash is equal to, this F is very close to the F. Therefore, Fp divided by Fa dash is equal to F is known as a focal length divided by minus V plus F. So when we compare both the equation, one side is the same, that is AP divided by A dash B dash is the same, means the other side is also same. When we take the other side, that other side is equal to, we take the other side and that other side is Fn divided by Fa dash AP divided by A dash B is equal to AP divided by A dash B is equal to Fp divided by Fa dash. AP divided by A dash B is equal to Fp divided by Fa dash. Substitute the value of AP by A dash B. Those values are minus U divided by minus V. Minus U divided by minus V is equal to Fp is equal to minus F divided by this value is minus V plus F. Minus V plus F. So cross multiply this equation. This minus plus. Cross multiply this equation. When we cross multiply this equation, U into minus V minus UV is equal to U into minus V, that is equal to minus UV, and another one is a UF plus the UF is equal to this value minus VF minus F into plus V, that is equal to minus VF. So arrange this equation. When we arrange this equation, UF plus, take this side VF, so minus UV this side is equal to UV. When we divide this equation by UVF, divide this equation by UVF, means when we divide this equation by UVF, and this is also equal to UVF. So when we divide all this equation by UVF, see here U get cancelled, F get cancelled, and the remaining value is 1 by V. The remaining value is 1 by V plus VF get cancelled, and the remaining value is 1 by U. UV get cancelled, and we got here 1 divided by F. So this equation is known as a mirror formula. That mirror formula is equal to 1 by V plus 1 by U is equal to 1 by F. So F means focal length, U means object distance, and V means the image distance. So this relation is known as a mirror equation, or this formula is known as a mirror formula. So here this is a very easy derivation. In this derivation, we consider the first triangle ABP, or we draw the perpendicular from M to N. That is, the first triangle is ABN, and the second triangle is A dash, B dash, and M. When we compare both the triangles, we got here AB divided by A dash, B dash is equal to AB divided by A dash B. So this AB means the object distance, and that object distance is equal to minus U, and this A dash B is equal to minus V. Because according to the Cartesian side, all the distances are measured from the pole, and the directions are taken to be positive in the same direction of the incident ray. ಅದೇ ನಾವು opposite direction ಇತ್ತಂದ್ರೆ ಅದಕ್ಕೆ minus ಅಂತ consider ಮಾಡ್ತೀವಿ. So here this is a minus U and this is a minus V. So second part. Again we consider the another two triangles, and the another two triangles are A dash, B dash, F, and the another one is a F, M, N. So when we compare these two triangles, again we compare the similar sides. That is a MN divided by A dash, B dash. MN divided by A dash, B dash is equal to another similar side is FN divided by FA dash. So here MN is parallel to AB. MN is parallel to AB. So replace this value. When we replace this value, MN is equal to AB. Therefore, AB divided by A dash, B dash is equal to FN divided by FA dash. So here, one side is the same for the equation 1 and the equation 3. Because where N is very close to the P, and the distance are measured from the pole, and n is very close to the p. Therefore, replace the value n by p. That is the fp divided by fa dash. So when we replace this value fp divided by fa dash, these two sides are same. Means fp is equal to, see this, fp is equal to, this is the focal length. Incident ray is in this direction, and we measure the distance in opposite direction. So this is a minus here. And again, the second part is a fa dash. This fa dash is ಅಲ್ಲಿ particular value ಇಲ್ಲ ಅದನ್ನು ಚೇಂಜ್ ಮಾಡಿ fa dash is equal to pa dash minus n f of p. That is a fa dash is equal to pa dash minus p. Therefore, pa dash is equal to minus v. According, apply the Cartesian sign. pa dash is equal to opposite direction. Incident ray is in this direction. So we consider here minus. This is a minus minus plus. Tf is equal to opposite direction, means minus here. But here already one minus. Minus minus plus. That is minus v plus here. So this is the value of it fa dash. Therefore, fp divided by fa dash is equal to minus f divided by minus v plus f. So one side is the same. That is ab by a dash p is the same for the equation 1 and the third equation. So the other side is also same. So replace the value. That is the u by v. ap divided by a dash p is equal to fp divided by fa dash. We got the value of ap is equal to minus u. And the value of a dash p is a image distance. That is a minus v. Minus minus plus is equal to this f is equal to minus f divided by fa dash minus v plus f. Then cross multiply this equation. U into v minus uv. Again plus and minus plus u f plus u f is equal to this v and minus f is equal to minus v f. Arrange the equation. That is a uf plus uf. This minus come to this side. uf plus vf is equal to uv. Divide all the three equations by uvf. ಮೂರು ಇದರಲ್ಲಿ ಡಿವೈಡ್ ಮಾಡ್ತಾರೆ uvf. So here u get cancelled, ff get cancelled, and the remaining value is a 1 by 3. Here the 1 by u is equal to 1 by n. So this equation, this derivation is a very important for the numericals as well as the derivation famous part. That is a mirror formula or derive the equations for the mirror equation. Next part is a magnification. Next part is a magnification. Magnification. Magnification is defined as the ratio of a height of the image divided by height of the object. Magnification is defined as the height of the image to the height of the object, or the distance of the image to the distance of a object is known as a magnification. This magnification is the change in size of the object. So magnification is defined as it is the ratio of height of image to the height of object. Height of image to the height of object is known as a magnification. So when the image formations are there, when we got the image is a changes. That is known as a magnified. When the image height is more than the height of the object, that image is known as a magnified. And when the height of the image is less than the height of a object, at that time that image is said to be diminished. So to find out the image is a magnified or a diminished, we use the formula magnification is equal to height of a object, height of image, height of an image to the height of object, to height of object. So see the figure. Height of image is equal to a dash b dash, a dash b dash divided by height of object is equal to height of object is known as a AD. So a dash b dash is equal to height of image, that is equal to HR divided by height of a object, that is AB, that is equal to height of a object. And we know that this height of image is taken to be minus, because according to the Cartesian sign, the height above the principal axis are taken to be positive and the height below the principal axis are taken to be negative. So here the image is in the downward direction. The image is in the downward direction, means that height is taken to be negative. So this is equal to minus. On this height of a object, height of the object is above the principal axis. This it is considered to be HO. Means magnification is equal to HR divided by HO. So we take your magnification is equal to HI divided by HO. So if we derive this or if we use the another one formula, this is equal to minus V divided by U. Means image distance divided by object distance. So this is a related formula to find out the magnification. So here magnification is a diminution. If here if HI is equal to HO, if HI is equal to HO, means height of a object and height of a image is both are same. So that time magnification is equal to 1. When the height of image and height of object is equal to 1, so that time we consider here magnification is equal to 1, means the image is find out as it is. Otherwise, if the image is a less than object, that time we have got here minus sign. So in this type of, we use this formula for the numericals. That is the magnification is equal to height of object as well as the height of a image. So in this chapter we study the ray optics. In this ray optics we study about the reflection as well as the laws of reflection, as well as we study about the number of ray diagrams, as well as we derive the derivation, first derivation, that is the focal length is equal to r by 2, as well as we study about the mirror formula, that is the 1 by f is equal to 1 by u plus 1 by is v. Means when we use these formulas for the numericals, we apply the Cartesian sign, plus or minus. So in the next class, we study about the refraction.
End straight now.